Good afternoon. Today we're just going to work through a few problems for section 5.8. It's going to be a relatively easy and a relatively short one. Not very important, but just going to bop through it fairly quickly. And then just keep in mind, next Tuesday is our chapter test day for chapter 5, so make sure you're working on both the regular homework and then the chapter review, which will be due on Tuesday. Okay? Well, 5.8, essentially what we do here is we just take all of our different geometry problems that we've been working with, and we apply them to our XY coordinate system. So we take all of our triangle problems that we've been working on. So our congruent triangles and our corresponding parts and all of the rest. And we just essentially are connecting all of those to the XY coordinate system. All right? And so we're essentially just going to be placing triangles then on our coordinate system. So, just a nice obvious one would be something like create the triangle where one vertex is located at 2, 2, another is located at 6, 2, and another point might be located at 6, 4. So we could create a triangle from those three ordered pairs, 2, 2, 6, 2, and 6, 4, that sort of thing. Okay? And then using the triangles in those new positions, then we can do our proofs using sides and or angles. The angles are going to be a little bit tougher, but the sides are fairly easy, because if we ever need to find a side length, like as an example, we wanted to find the length of this side right here, we could actually find the exact length using distance formula. Okay, so that's the idea. And what we're going to start with is some problems where we just ask you to practice putting a shape onto a coordinate system. So as an example, just to kind of get you the feel for it, what if I asked you to draw a scalene right triangle onto a coordinate system? Okay? Well, you guys have the freedom to put it essentially anywhere you want, but sometimes there's going to be more logical places to put it than others. Now, don't write down the following, but you could just simply put a scalene right triangle in a position like this using this point, and this point. And what you'd have is a triangle where all three side lengths are different and there's a 90-degree angle. That's fine. But sometimes there's more convenient places to put triangles like that. As an example, if you have the freedom to put it anywhere, you could place one vertex at the origin, one vertex a certain distance up the y-axis, and and the third vertex a certain distance out on the x-axis. So if I do this in a different color so you can see it, then our triangle, where all of the sides would be different length, scalene, and the one angle then be 90 degrees, and we know it's 90 degrees because it occurs at the origin. Okay, so sometimes there's more convenient places to put our shapes. Okay, so that's just kind of the idea to start with. Just as an example, a couple more examples. In your assignment, you're supposed to do numbers 1 through 10. And as an example, number 1 says, place a figure in a coordinate plane in a convenient way. And number 1 says a right triangle with leg lengths 3 and 2. So a nice, simple, convenient way to put a triangle with legs of 3 and 2 would be to use 3 on the x-axis, 2 on the x-axis, 2 on the y-axis, sorry about that. So I should write that down. 2 on the y, 3 on the x. And then what we'd have is a triangle, right? A right triangle with side lengths. This side would be 2, this side would be 3, and because we did it at the origin, it would be a right triangle. Okay? Not too bad, right? Not very difficult. Number two asks you to put a square in with a side length of 3. And there's, again, an infinite number of ways to do that, but what's a nice convenient way to do that? Well, we could actually place the square, so one corner, one vertex of the square is at the origin, and then it says the side lengths have to be 3, so we could just simply go out 3 to the right, up 3, and then up 3 and right 3, and we could just then use the x-axis, y-axis, and then a horizontal and a vertical, and all of those side lengths then would be 3, and we'd have our square. Okay, so you can kind of tell there's convenient ways to do that. Number 3 as an example. Number 3 as an example says an isosceles triangle with a leg length of p. So isosceles triangle with a leg length of p. Okay, again, you do this in a whole bunch of ways. But one way to do this would then be to, excuse me, would be to go out on the x-axis a distance of p. Please notice I didn't put the little tick marks in between because we don't know how big p is. We're just saying it's p. And however long that is, let's just do the same thing up vertically. Let's go vertically p. And when we create a triangle between the origin, P up the y-axis and P over on the x-axis, and if of course just connect those two, we then have a isosceles triangle because these two distances are equal and they're each a distance of P. So that's an isosceles with leg length of P. Okay? So, and then I'll just leave number 4 for you guys to do, just a little bit different there. Okay, then the next batch of a couple ask you to do the same thing and then find one of the other sides. So as an example, let's see what color am I in black here. So number 5 asks you to draw a right triangle with leg lengths 7 and 9 and then find the length of the hypotenuse. Okay, so that's fine. So first they want you to draw the picture and they want the legs to be 7 and 9. So I could go up 7, 1, 2, 3, 4, 5, 6, 7. I could go right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And put in my triangle using those two sides. And then connect the 2 points to create the triangle. Obviously we're creating the triangle there. And then what they want me to do is find the length of the hypotenuse, which is of course across from the 90-degree angle. So we'd be finding the distance from this point, 0, 7, to this point, 9, 0. And our distance formula says that the distance between 2 points is the difference of the y's squared, so 0 minus 7, plus the difference of the x's squared, 9 minus 0 squared. And when you guys do that arithmetic, 0 minus 7 is negative 7. 9 minus 0 is 9. Negative 7 times negative 7 is 49. 9 times 9 is 81. And then 49 plus 81 is 130, I think. And that doesn't turn out perfect, but let me approximate that for you. I just have to grab a calculator. And so the square root, hit the wrong button. Square root of 130, try that again. Square root of 130 is about 11.4. So the distance between those 2 points, which is then going to be the same as the hypotenuse, is approximately 11.4. Okay. And again, I'll let you try the next couple. I'll let you guys try 6, 7, 8 on your own. Okay? So it's just, again, placing whatever they want you there. Like number 6 is an isosceles triangle. Number 7 is a rectangle. Number 8 is a square. All right? So that's just asking you to place those. And then find one of the missing pieces. Find one of the legs, find the diagonal. It's asking you to do that. Okay? And then the next two in that batch, number 9 and 10, as an example here, number 9, asks you to take these 3 points, 0, 0, HH, and 2H, 0, and create a triangle with those. Okay? Now, since we don't know the exact length of H, we just go out a generic distance. So we know A is at 0, 0. Okay, so no sweat there. B, we have to go H to the right, whatever the heck that is, and we have to go up H. So point B then is going to be located right there. And then C is located 2H, 0. So instead of going to the right 1H, we have to go out 2 H's. And that's going to be where C is, 2H, and then we don't go up or down. So it's at 0. And when we do connect the dot puzzle, A to B to C, and then back to where we started, that's our triangle. So that's the first part. Okay, we've drawn the triangle. Now what it says is find the length and slope of each side of the triangle. So lengths are going to be distance formula. So what we're going to be looking for is the distance between A and B, the distance between B and C, and the distance between C and A. Now that one, of course, that one we could shortcut because A to C is just a flat horizontal line, so we're going to know how long that one is. But the others, though, we have to go through the work. For AB as an example, we'll have to subtract the y's, so h minus 0 squared, and then subtract the x's, h minus 0 squared. So what we end up with is h minus 0, which is h, squared, h minus 0, h squared. So we get h squared plus h squared, which is 2h squared. And we did this in algebra last year. I don't know if you guys would remember, but we can take the square root of h squared, and what we'd end up with is the square root of 2 with an h on the outside. And if you don't remember that, that's fine. We could just leave it as it was. BC, same idea. The difference of the y's, 0 minus h squared, and the difference of the x's, 2h minus h squared. So what we'll end up with is negative h squared and h squared. So once again, we end up with the square root of 2h squared, which would be the square root of 2h. And then finally, AC you could simplify. You don't have to go through all of the work because it's just horizontal. So the length of that line is just going to be the distance from 0 to 2h, which would be 2h. Okay, so they wanted you to find the length of each side of the triangle. So we did that. Then they wanted you to find the slope of each side. So they're asking for the slope, I can't read that. The slope of AB, the slope of BC, and the slope of AC. Okay, so slopes, we subtract the y's, divided by subtract the x's, and simplify. So for AB, subtract the y's, subtract the x's, so that's rise over run, and what we end up with is h over h, so we get positive 1. For BC, subtract the y's, so 0 minus h, subtract the x's, 2h minus h, so we end up with negative h over h, which is negative 1. And finally, for AC, you know you're going to get 0 as a result here. But if you don't recognize that, that's fine. Subtract the y's, 0 minus 0, and subtract the x's, 2h minus 0. So we end up with 0 over 2h, which is 0. So we have the slopes for each of those. Okay? Now, in the problem, it also asks, is this a right triangle, and is it isosceles? Well, is it isosceles? The answer is going to be yes, because 2 of the side lengths are exactly the same. So therefore, you know it's going to be an isosceles triangle. Okay? And is it going to be a right triangle? The answer there also is yes, because 2 of the slopes are negative reciprocals of each other. So this is going to be a right isosceles, which means we'd have a 90-degree angle, and these 2 sides are equal. We'd have a right isosceles triangle. Okay? Alrighty. And then finally, the last thing that they want us to do in this section are some proofs involving using a coordinate system. And so I'm going to run through one of those with you, and then that'll be it for us. And the one I was going to do is number 14. All right, so I'll take a quick photo. Let's see, there's 14. Let me highlight and crop this up. So there we go. So there's your picture, the given information, and what we're trying to prove for this problem. Get my proof ready to go here. Okay, and like always, we start with given information. So we're going to start with G is the midpoint of HF. So that's given to us. All right, so in our picture, G being the midpoint of HF means that the distance from H to G and the distance from G to F are the same. So we can make that our next statement. H to G and F to G are going to be the same using the definition of midpoint. Okay, now since we're trying to prove that triangle G, H, J, which I'm going to call the upper triangle, so GHJ, this upper triangle, we're trying to prove that that's congruent to GFO, so G to F to O, the lower triangle. What we have right now is a side of each. We have a side of each, okay? Now, from the picture, we can tell that the angle above G and the angle below G are equal. So we're going to be able to say that angle 1 equals angle 2 because those are vertical angles. So what we would then have is an angle in each triangle. So what we're missing is either another side or we're missing another angle. And I'm going to choose to get another side by finding the length of GJ. Okay, so I'm going to get the length of GJ by applying distance formula. Because G is a midpoint, we know that the ordered pair then has to be halfway between 1 and 5, which would be 3, and halfway between 0 and 4, which would be 2. So we can then use distance formula to get the length from G to J, so the difference of the y's, so 4 minus 2 squared, plus the difference of the x's, 6 minus 3 squared. So when we do the arithmetic, 4 minus 2 is 2, 6 minus 3 is 3, 2 squared is 4, 3 squared is 9, 4 plus 9 is the square root of 13, and the square root of 13 is about and I'm going to get it for you on my calculator. Square root of 13 is about 3.6. So what we're able to say then is the distance from G to J is 3.6, and we used the distance formula. Okay? Then we have to find the distance from, G to O, so from G to O, and we're going to do that once again with distance formula. So we're going to find the distance from G to O with the distance formula. So we'll subtract the y's, so 2 minus 0 squared, and subtract the x's, 3 minus 0 squared. So 2 minus 0 is 2, 3 minus 0 is 3, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13, and the square root of 13 is about 3.6. So once again, using distance formula, all right, we know that length. And because we have two things that are each equal to the same thing, GJ equals 3.6, GO equals 3.6, we can use the transitive property and say GJ equals GO. Again, because we have two things that are each equal to the same thing. And if I put some tick marks on my picture, GJ and GO are the same length, and what that gives us is another side. So the last step, I just need one more little line here, And the last step then is that the two triangles GHJ and triangle GFO are going to be congruent to each other. And the reason you can see here in the margin, SAS. Okay, but we did the proof using the XY coordinate system. Okay? Alrighty. So that's it. That's about all there is. There's one more proof that I'm going to have you guys try on your own, number 15, and then a couple of the initial problems that I didn't do with you. Okay? So we'll see you on Monday. Get to work on the assignment and get as much done as you can.